Good morning, everybody. Welcome back to lecture number 21. So I'm going to ask you, please, before, put pause on the YouTube video and watch this video first. Because this video is more basic than this video. But we will not have time except to play this video. Okay? Now, do we have sound? Yes. No, we don't have sound.
Today, we're checking
Now
out
we have sound.
Reader, a gem of a tool for notes, proposals, emails, and everything.
You can find DC motors in many portable home appliances, automobiles, and types of industrial equipment. In this video, we will logically understand the operation and construction of a commercial DC motor.
طيب before we start المواضيع كيف تجي؟ تجي في casing أو external casing, okay? Usually we put them in a casing. وفي هنا lead connection positive, red is hot, and negative, black. There is always a shaft made usually of aluminum. What is the purpose of the shaft? To provide axis of rotation. Can I أحط الحفرات كده على طول؟
ايش استفدت؟ ما استفدت.
بس في احتكاك.
No, we connect this to another bar على gearbox, تروس, والتروس هاي تحط لي ناقل الحركة اللي أبغاه. Okay? Don't ever think that you put the tires here and you move the car. Okay? Now, why we have these holes?
عشان الهواء يدخل.
Cooling. صح? Cooling. You agree with me?
Yes.
And we have this structure. Why do you think we have this bar? To hold it. Okay? To what? Hold it. So let's watch this YouTube video.
Automobiles and types of industrial equipment. In this
Complicated.
video, we will logically understand the operation and construction of a commercial DC motor. Let's first start with the simplest DC motor possible. It looks like this. The stator provides a constant magnetic field, and the armature, which is the rotating part, is a simple coil. The armature is connected to a DC power source through a pair of commutator rings. When the current flows through the coil, an electromagnetic force is induced on it according to the Lorentz law, so the coil will start to rotate.
Stop. هذا ايش؟ copper. هذه زي القوس. made of copper. مشبوك مع الكويل. الكويل هل هو one cable ولا multiple cables band? We put them together. Put them together زي transformer to increase the flux والاشياء هذه. What is happening here إنه هذه إذا دار الكويل هذه راح تدور وهنا في زي الجاب. هنا في ايش؟ gap. Let's see.
You will notice that as the coil rotates, the commutator rings connect with the power source of opposite polarity. As a result, on the left side of the coil, the electricity will always flow away, and on the right side, electricity will always flow toward. This ensures that the torque action is also in the same direction throughout the motion, so the coil will continue rotating. But if you observe the torque action on the
Before
coil,
that, do you see this blue arrow? Does it change its direction ولا لا؟ ركز.
action is also in the same
Blue arrow.
direction throughout the motion, so the coil will continue
Yes.
rotating. But if you observe the torque action on the coil closely, you will notice that when the coil is nearly perpendicular to the magnetic flux, the torque action nears zero.
ليش zero؟
As a result,
ليش لما يوقف كده على فوق يصير zero؟ لا.
90
It's 90, but there is a simpler another reason.
اللي تحت كمان
الفتحة حقت هذه موصولة هنا فما يوصل كهرباء.
على الكاب قصدك؟
على الكميوتيتر هذا اسمه كميوتيتر. دائرة هذه الحلقة. الحلقة ما هي دائرة كاملة، حلقة كذا. فهو لما يصير فيرتيكال يصير كذا. فما في electricity provided. بلس ان الفلكس هنا perpendicular فالفورس ما doesn't exist. بس انه اساسا ما في كارنت، اساسا ما في كارنت. يعني ما في كارنت. نزي. تمام.
دكتور
Please at least the video. At least.
دكتور الحين اتجاه السهم هذا هو اتجاه الكرنت صح؟
لا الازرق ولا الاحمر؟
على ازرق.
الازرق هو اتجاه الكارنت. Apply the right hand rule that I don't know how to use.
كذا كذا.
I don't know how to use. I'm not gonna do it. I don't know how to use. You do not need to know. Just know it's opposite of each other. It creates torque. You really don't need to know it in details. The only one you need to know is the easy one. If you apply it, keep that. It's easy. It's done for you. See what will happen.
There will be irregular motion of the rotor.
Irregular
From
motion.
such a DC motor.
شوف يبطأ يسرع يبطأ يسرع يبطأ يسرع يبطأ يسرع. الجاذبية تدفع.
Here is the trick to overcoming this problem. Add one more loop to the rotor with a separate commutator pair for it.
وش سووا؟ مجانين
This
هذول.
arrangement with motor.
في ال 1950s مجانين تسلا I think they are better than us صراحة. Without AI, without anything, just thinking how it happened, is something very good.
You will notice that as the coil rotates, the commutator rings connect with the power source of opposite polarity. As a result, on the left side of the coil, the electricity will always flow away, and on the right side, electricity will always flow toward. This ensures that the torque action is also in the same direction throughout the motion, so the coil will continue rotating.
والكميتاتر راح يدور.
But if you observe the torque action on the coil closely, you will notice that when the coil is nearly perpendicular to the magnetic flux, the torque action nears zero. As a result, there will be irregular motion of the rotor if you run such a DC motor. Here is the trick to overcoming this problem. Add one more loop to the rotor with a separate commutator pair for it.
Separate commutator.
In this arrangement, when the first loop is in the vertical position, the second loop will be connected to the power source. So a motive force is always present in the system.
Can we do more? Please.
Moreover, the more such loops, the smoother will be the motor rotation.
See? مو كان هذا الشكل
In a
معلوم.
practical motor, the armature loops are fitted inside slots of highly permeable steel layers.
Highly permeable. Why highly permeable? First of all, remember lamination? Why they're laminated? هذا core. هذا زي الكور. Why they are laminated? AD current. Okay. السلاتس هذه الحفر. Why we have them?
تمشي كرنت.
To enhance the magnetic flux plus give it stability. شو يقول هذا؟
تذكر شوي لو دخلناها على بعض ايش هيصير؟
The more such loops,
You
the
still have
smoother
this
will be the
in
motor rotation.
Have to watch this
In
video.
a practical motor, the armature loops are fitted inside slots of
Thank you.
highly permeable steel layers.
Highly
This
permeable.
will enhance magnetic flux interaction.
حط الشيء.
Spring-loaded commutator brushes
Spring.
help to maintain contact with the power source.
عشان الهزم.
A permanent magnet stator pole is used only for very small DC motors. Most brushes help to maintain
هذا حق العاب
contact
الاطفال
with the
الموتر
power
حط له
source.
مغناطيس بس تجي
A
موتر
permanent magnet
كبير.
stator pole is used only for very small DC motors. Most often, an electromagnet is used. The field coil of the electromagnet is powered from the same DC source.
Okay. Now.
The field coils can be connected.
ايش سووا؟ بدل المغناطيس حط what we call stator laminated حط coil هنا وحط coil هنا apply right hand rule
الاثنين بنفس المنتج الشاب.
apply right hand rule reflex going this way كأنه مغناطيس I don't need to put a magnet why but nowadays some electric vehicles they have magnet
وش ارخص للماجنت؟
أرخص هذا الماجنت when you talk about AC machine له علاقة بالسynchronization والكنترول
بس هذا دكتور ما يستهلك الكتريسيتي اكثر؟
Hmm?
يعني الكرنت حيمشي على
Yeah, that's the conservation of misery. You're paying more by having electricity, but you're saving money by not buying a magnet. Magnet is expensive. Buy a big magnet is expensive. Are you familiar with the scrub? When this magnet in the scrub,
ايوه
they use it. I think they don't use a magnet. They use electric power. صح؟
Because
mean
they
that-
can
تشريح.
on and off.
On and off تشريح. تشريحي عندهم هذه الحديدة اللي تشيل.
صح لانه يشغلون الكهرباء تشتغل.
Same concept.
These source.
Right hand rule that I know how to use.
The field coils can be connected to the rotor windings in two different ways, parallel or series. The
Parallel.
result is two different kinds of DC motor construction
Series مع نفس الروتر.
and a series motor.
Parallel يعني بطارية is parallel. Series يعني نفس
البوستيف مع البوستيف.
يروح على الكميتيتر in series يعني يوصل الفيلد اللي يطلع الدائرة اللي تعطيك المغناطيس in series مع الدائرة اللي تمشي في الروتر. يدخل الكميتيتر. هنا parallel. سيريس يعني نفس الكرنت هنا يدخل. parallel يعني نفس الفولتج.
اتوقع انه برا افضل صح؟
Each has advantage you will talk about.
The series wound motor has good starting torque, but its speed drops drastically with the load. The shunt motor has a low starting torque, but it is able to run almost at a constant speed, irrespective of the load acting on the motor. Unlike the other electrical machines, DC motors exhibit a unique characteristic, the production of back EMF,
I'm not going to talk about back EMF, but
a
basically back.
rotating loop in magnetic fields will produce an EMF according to the principle of electromagnetic induction. The case of rotating armature loops is also the same. An internal EMF will be induced that opposes the applied input voltage. The back EMF reduces armature current by a large amount. Back EMF is proportional to the speed of the rotor. At the starting of the motor, back EMF is too low, thus the armature current becomes too high, leading to the burnout of the rotor. Thus, a proper starting mechanism that controls the applied input voltage is necessary in large DC motors. One of the interesting variations of the DC motor is a universal motor, which is capable to run under both AC and DC power sources. To know more about it, please check the next video.
Now,
Thank you.
machines really
Imagine being able to build an app with your name on it.
machines are really important to watch as many videos as possible. You cannot learn them by reading the book alone. You really need to have simulations, etc. So watch this and watch this one. I think has some clarification على الكميتيتر. I think if you don't have time, just watch it. But just watch this before, then watch this video. Any question about the video? Any question? Clear, صح? So now I intentionally showed you the video, even though you can watch it at home, because now when I explain stuff, you have some idea. So first of all, what is the stator? Do you remember what was the stator in the video? stator. إيش معنى stator؟ ما يتحرك.
حديدة هذيك.
الحديدة اللي برا.
ايه
الحديدة اللي برا الدائرة. Which is this outer thing. It has different shapes, but one of the shapes might have slots that we can put coil inside them. Sometimes it is smooth, ما فيها حفر, and we put a coil inside. So there are different designs. It's not only that, we have also rotor. Rotor جزء اللي يدور. It can be shaped this way like the one in video, or it can be shaped like that shape. This shape has mechanical advantage, يعني يعطيك inertia.
ودكتور الحلقة ذيك شو اسمها؟ اللي كانت
روتر.
روتر؟
اي روتر يعني يدور. ستيتر يعني ساكن.
طب واللي جوا ذيك اللي كانت مربوطة بالروتر؟
الكوميتيتر. It's outside. كوميتيتر. كوميتيتر هي ميكانيكال ستراكشر يحط فيها سبرينج تدور معاها. لأن أنت عندك دي سي لما تدور الروتر كيف الدي سي بتوصله لهذا؟ التريك اللي اخترعوها الكوميتيتر اللي هي حلقات بحيث انها كل ما تدور كل ما توصل كهرباء. So the part that doesn't move is what? And the part that does move is rotor. Rotor, move outer. Rotor. 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 Usually it's inside. Some of the machines the rotor is outside. Okay? Before we go to convergent, let me ask you a question in physics. What is the unit of torque?
نيوتن.
Wrong.
بالمتر.
Newton is fine. What is the Newton? Force. What's the unit of force? Kilogram, meter,
فورس اس
square, times. So what's the unit of torque? Kilogram, meter square, or second square. What is the unit of omega? Radian per second. If I multiply radian per second, if I multiply these two, what should I get? Kilogram, meter square, radians over second cube. Let's go to Wikipedia and look at the definition of watt. What's the unit of watt? Is it the same? Kilogram, meter square over second cube. The only thing is I'm multiplying it by radian. Radian, I can make it degree, it doesn't matter.
Yes, you can take that.
It's unitless, يعني ما. Isn't this watt?
Yes.
So torque times omega is what? Power. Get it?
والراديان
Hmm?
والراديان صح
It is an angle يا أخي. I can say degrees. هنا في عندك يعني speed meter per radian is omega. Doesn't matter.
راديان يعني فاز
No, يعني. Yeah, it's an angle.
انجل فاز
Well, think of it as يعني شلون اشرح؟ I love Wikipedia stuff. What is this? Decawa, hectawa, kilowa, megawa, gigawa, terawa, petawa, exawa, zetawa, utawa, ronawa. New information. أول مرة أشوف. Witawa, 10 to 30. I didn't know. They exist. Doesn't matter. But are you also familiar?
دكتور نقدر نقول ان الباور عبارة عن التورك في الفريكونسي صح؟ تورك في الفريكونسي
لا مو frequency. Angular frequency.
انجل
Over 2 by frequency.
Hmm?
Over 2 by frequency. Over 2 by frequency.
لأن الفريكونسي يديني 1 over second كيف حيعطيني في حيعطيني نفس
يعني أنت you're saying I should divide by 2 over 2 pi radian?
إيه
divided by 2 pi.
حتروح
Frequency will run over it's 1 over second. So we start I think the information, the units even more.
لا اتوقع دكتور ما بتدرك، يعني هنا بيعطيك الباور بالراديان، هناك بيعطيك في الدقري.
Well, because listen, let me tell you, is our movement linear ولا دهولي? Is our movement linear or angular?
Angular.
Is our torque applied angular or our torque applied linearly?
Angular.
That's why there is radian. No need to divide by anything. So this radian, it tells you that's an angular torque you apply. So keep it. That's the right way. You have two different types of torque. The angular torque, اللي هو كده, فهو torque is angular. What else we had? Volts times current. صح? Power. Maybe plus some eta, these are maybe losses, friction, heat, etc. So we all know that I can convert mechanical energy back to electrical and vice versa. So for the electric machines that we just opened in YouTube, if I spin it, would it produce electricity? Yes. If I provide it with electricity, would it spin? Yes. So in general, we call them, if I don't know the application, I call it electric machines وأسك. But what's the title of this chapter? DC motor. It means we'll focus more on the motor application. Get it? Not only that, the components and the construction details of motors and generators are very similar. Generator can operate a motor or vice versa. Plus losses. Don't forget there is losses. Right? Right and correct? It's not only that, I can use this equation, omega times torque. Can I say the torque tau, not T?
Yes.
Equals VI. So electric machine converts energy according to the law of conservation of energy. Without losses, this equation holds true. These are the units that I just was talking about. So the angular torque should have rating. Let's bring our coil again. It is known that if a coil is rotated in a magnetic field, the voltage is induced. Where is this voltage induced? Is it induced here?
The small gap.
Plus here, minus here?
No, the small gap.
Plus here, minus here. Terminals. So, magnetic flux lines going up, if I increase them, what will happen? Would the induced voltage becomes larger or smaller? Right. If I increase the number of flux lines, would the induced voltage be larger or smaller? Larger. Correct. If I increase the length or deep, what will happen?
Decrease.
Or larger.
تزيد المساحة حتى
Yes. You increase the area where the flux is going. What if I increase the speed, V, of rotation? I'm running as a motor. No, I'm running as a generator, sorry. If I run it as a generator and I spin it faster.
Should be more.
More.
الروتيت استقرار أكثر.
That is correct. So F is the number of cycles per second, how many revolutions are made. It is a function of the speed rotation. So can I say, let's say that I am standing here. الكويل ما يتحرك. How do I view flux lines? Are they constant or variable?
Flux?
Lines.
Constant.
لا
constant or variable?
Constant.
There is no flux lines. It's constant.
الكويل ما يتحرك ثابت. في رجال واقف على الكويل. كيف هو يشوف الأسهم هذه بالنسبة له؟ ثابتة ولا متحركة؟
عشان ثابت. ثابت.
ثابتة.
اي.
طيب بدل الكويل يلف ويدور فيه يلف.
انت شوف تتحرك.
يشوف الأسهم ايش؟ متحركة. Get it? So because it's circular motion, I can model it as a sinusoidal movement. Cosine omega. Flux is cosine omega t. So the coil rotates, it cuts the line, the flux appears to be changing with time because I'm moving the coil with time. Can use this equation. Do you remember BA? Formula sheet that you guys
Yes.
ruined it for us. What will happen? It's ruined. خلاص. It's not gonna happen. We're not have a formula sheet.
الميجر طيب.
That is the problem with me. So what is happening? B times D times L is BA. What is BA?
ديال.
Flux. Maximum flux. What is omega 2 pi f area dl flux max BA? What is happening here? Do you remember Faraday's law? The voltage appears is n times change of that flux. There is a typo here, add negative sign. Because derivative of cosine is minus sign. There is a negative sign. Add negative sign. But it's not important. I don't care.
اصلا في نيجاتيف في القانون من قبل.
I think there is a negative in the formula.
عند فورمولا في نيجاتيف الحين صار بوزيتيف.
At least in
It
three
doesn't
formulas.
matter. Okay, you want it here?
اي يعني قصدي الناتج في النهايه.
I'm not going to ask you in the test about this formula directly. The key here is when you look at machines, sine or cosine, it doesn't matter. In power systems, you can model it as sine or cosine because at 90 degrees of time, which is quarter a cycle, you will have the peak to be minimum. The peak to be zero. At 180 degrees, the peak will be minimum. يعني it doesn't matter whether you model it cosine or sine, it doesn't matter. A professor that I was working with when I was doing my grad school, his name is Dr. Tom Habitler. He used to focus more about, يعني he was very expert. His professor, يعني his professor was author of a book that is well known in electric machines, Professor Lepo. Long time ago, he wrote the book. But when they write these equations, sometimes they put sine, sometimes they put cosine. It doesn't matter. For you, you need to think about the concept. Okay? It's changing sinusoidally. Means it goes to 1 minus 1. هذا الموديل. As a matter of fact, when my professor finished his PhD, he was supposed to work with General Motors. No General Motors? Jumus. But he ended up becoming a professor because he loved his field. Back then they were manufacturing the EVs, and you don't think the EVs are new. Are the EVs new? Is it something new?
No.
في الثمانينات والسبعينات في سيارات كهربائية. Is now they're becoming more economical. There is more need to do them right now. I'm not gonna buy it. Hmm? It's not worth it. Safety it's good. It's a good thing, but it's not worth it. يعني تمسك فيها خطوط وكده. It's good for the city. Anyway, let's do the voltage. Let's take the RMS. What is the RMS of a sine? Peak over square root of 2. Peak n phi omega over square root of 2. You agree with me?
Yes.
Can you do calculators 2 pi over square root of 2?
4.44.
Correct. So this equation, the RMS voltage is 4.44 times flux times N times N. So away from maximum flux, let's define this voltage to be E induced. If you combine the equations, etc., you will have a constant K. This K is not this number, by the way. This K is a function, a constant representing the construction of the machine. It is Z times P over 2 pi A. What is Z? Total number of conductors, number of current paths is A, P is number of poles. We'll talk about it later. The key here I want you to know is the flux, if it's constant, the induced voltage will be constant. But because I'm moving, the flux appears to be rotating in time. Don't confuse the two things.
دكتور الحين في الريل لايف اكزامبل نقدر نحسب الكوندكتورز ونقدر نحسب البولز يعني الزد والبي سهل بس كيف نحسب الكرنت باثs؟ ولا بتكون مثلا معطى ولا كيف؟
Yeah, we will solve the problems. But the current path is how many paths? So the coil has.
اي يعني في المسألة أكيد بيعطيني العدد.
Don't worry about the مسألة.
بس أنا قصدي في
We're not going to talk about it. Yeah. In real life,
لا.
you look at the structure, you count them.
يصير بالصورة اللي شوي رسمة. We have one current path, صح؟
You have one path, yes. But sometimes they put two parallel current paths.
كانت باث مو من التصنيع إذا.
Yeah, it's a manufacturer quantity. The more you have, less induced voltage. Okay? Let me think. So I'm gonna finish early today because I don't wanna overrun the previous section. Can I replace the induced voltage with the V?
Okay.
Yes. If I replace the induced voltage with the V, I can write the torque as function of the K, the flux, and the current. That is the key about, because omegas will cancel. The only thing I'll have is K times the flux, which is, now again, this is the induced voltage. The omegas will cancel, and I'll have this equation, where equation 6 shows that the machine torque is a function of the magnetic flux and the current drawn by the machine. So the torque, to increase the torque, I need to increase the flux, or increase the current, or increase the constant, which is a parameter of poles, conductors, and the current path. We will define these quantities later, okay? I will stop here for today. There is a couple of announcements, okay? So announcement 1. Homework 3. Question 1, 3 points. Question 2, 7 points. Question 3, 5 points, and it's a bonus. You don't have to do it. If you do it, you will get 5 plus 10. 15 out of 10.
أقدر أخذ البونص في الكويز.
No.
مو كويز.
No, only on this one. Means if you don't know how to solve this problem will replace. No, I'm not gonna do carry on. Major 1, October 22nd. We'll have quiz 3, October 21st. We will have fake quiz 2 next week. Quiz 3 is going to be a mini major to take the whole class.
Excellent. Can we have the fake quiz on Thursday? Because I have Sunday and Sunday and Monday.
You want to have a fake quiz Thursday?
Yes.
We'll have. Now, what else we have? Help session.
Yes.
When did I say help session? It's going to be October 20, most probably. Help session.
That will be recorded.
I don't.
Which I have a major on that day, so.
Yeah, I don't care. Yeah. It's going to be remote, virtual.
Which is the
وش بدك تؤمن؟
There's the calendar.
الاثنين.
الخميس الجاي فيك كويز.
لا دكتور خليه نفسه 21.
نو فيك كويز فيك كويز.
هذاك ماني ميجر.
بعدين كويز 3 ميني ميجر 21 ميني ميجر. You'll have a يعني أكنه ميجر. Then you'll have the major. Then you'll have the session October 20.
When will you decide the material for the major?
I haven't decided. But for sure transformer is included. The debate is should we include DC machine or not? I think I'm going to include it. Would you rather have 4 tough problems without DC machine or 5 less tough problems with a DC machine?
5 is
Vote? No, you don't vote. I don't know what to decide. Get to vote on things like dates and position.
بس الميجر قبل الإجازة بيوم.
Yes. It's bad, I know.
طب دكتور البسيشن وين انت حتشرح فيه؟
It could be me, it could be the TA, we'll see. Most probably me. You want it to be in person and we record? Stream it live with Teams? I can stream the camera to Teams. You want to come in person? Who will come in person?
حسب الوقت.
حسب الوقت.
Well, 5 p.m.
Monday? ايوه.
Will you come?
صعب.
We can do it. Yeah, صعب those who live outside. صعب. It's those who live inside. Will you come?
maybe yes. Inshallah.
Okay, if you come, I'll remove 1 abscess.
Okay, okay.
Only. خلاص شباب. Please study hard. Things are getting much more very difficult now. I will try to adjust the equations. Maybe there is some confusion in the equations, and especially this one. I'll try to make it. But that's the thing I'm telling you about this equation. You know, induced voltage is K times flux times omega. If you put RMS, this has to be RMS. With speed, this is speed. If you put function of time, this is the function of time. Don't say K is this number. No. K is this number.
It has to be equal ولا ما له علاقة؟ الكونستنت اللي فوق وتحت.
It depends. If you're running RMS, yes. If you have theta max and you're calculating ERMS, yeah, then they will be equal. But that's not true always. Stick with this. We'll show examples. Once we show examples, you'll become familiar. The point here is that what I want you to learn is the following. To increase the torque, I increase the flux or current, or I mess with parameters in the machine. That's what matters. اللي باليد راسك. Okay? Let's check the camera status.
Yes. Still running.
Still working. Okay, توفيق يا شباب.